Welcome to my video activity for the module VTPA, that is Teaching Practice Part A. Today we'll be looking at a subject within our discipline and doing a bit of research on it. So my subject of interest is AET, which is Applied Engineering Technology. Shortly, I will be going through the assessment guideline as well as the subject guideline in order to see what are the subject outcomes and the learning outcomes in that module. Here I have managed to download the assessment guideline, which will be able to inform me on the subject outcomes as well as the learning outcomes for this module. Okay, from the assessment guideline, we learned that the subject and not module is comprised of 4 topics. Topic 1 is mechanical fundamentals of the engineering industry. Topic 2 is engineering practices are used to construct a structure prototype capable of bearing a point or distributed load. Topic 3 focuses on functionally dependent mechanisms are incorporated into a prototype of a technological solution, and the last topic is control system is incorporated into a prototype of a technological solution. Looking deeper into topic one, which is mechanical fundamentals of engineering industry, we learned that it is made up of 4 subject outcomes. 1.1 is explain the principles of mechanical engineering, and the learning outcomes in this SO are explain motion in engineering design. 1.1.2 evaluate surface finishes involving sliding motion and consider alternative to reduce friction. 1.1.3 consider the mass of matter with reference to its direct relationship to friction and the force required for motion. And lastly, 1.1.4 explain the inertia effect as a result of mass and its resistance to motion resulting in the force required. So that concludes SO 1.1. Yes, that concludes subject outcome 1.1 and its learning outcomes. So the module does have a lot of learning outcomes, which I will not be able to cover in this video alone. However, that was just to highlight what would be expected in the subject. Furthermore, looking at this module, I can see that it involves a lot of practical knowledge that you have to things that you can only understand by doing. So I think the best approach to this module is to actually engage learners into building small prototypes and test them out to actually see how this changing the structure or incorporating something different on the design structure would affect its integrity, and also how it will affect the forces applied on the structure as a whole. So in conclusion, I would say the subject must be approached in a practical manner and not a theoretical manner. You can incorporate video activities in the subject, but at the core of it will require students to actually engage with the material by designing their concept, choosing their final design, and ultimately building it and testing it to see if it meets the requirements. Or alternatively, they can simulate using CAD programs such as AutoCAD or SolidWorks to see or to test how various forces will affect the integrity of their prototype.